Whether you're working with wood, metal, or some other material, the drill press is a shop staple. In this video, I'm going to take you through the step-by-step setup procedure that I use to get optimal performance from my drill press. In this video, we're going to cover motor, belt, and pulley adjustments, as well as speed adjustments. We're also going to talk about feed spring adjustment, how to deal with looseness in your quill tube, run-out checks, table squareness checks, lubrication of your table head adjustment rail, and finally, laser center finder adjustment. Basically, everything to get your drill press in tip-top shape. Let's get started. So I've owned this drill press for about 2 years. This is the Porter Cable model. It's 15-inch standing model, PCB660DP, and it's been serving me pretty well, but it is one of the few machines in the shop that I haven't calibrated very precisely, and recently I had to drill holes that were a little bit more precise, and the issues that I've been having with it over the years have been amplified a little bit. So I'm going to go through the full tuning procedure and see if I can't get rid of some of those. The main issues I have are there's a lot of vibration in this thing, especially from the motor. It's been so bad that originally I actually put this bungee cord around it just to keep some vibration of the lid down, because the lid would dance all over the place. The other issues are when I drill deep holes, my bit starts to squeal a little bit, so that tells me that probably my table's out of square, and probably I have some run-out issues that I want to check for. Okay, with the belts removed, you can see the 3 pulleys. This is my spindle pulley, my center pulley, and my motor pulley. And the first thing you want to do is look for how each one of these is adjusted. This one is your traditional pulley with a set screw here. It means this one can move up and down on the shaft. The center pulley, it is not auto tension, it's just sits on this pin here and rotates around this bearing, which it looks like it's press fit in. I don't see any set screw on this pulley, so it's not adjustable as far as I can tell. Same thing with these pins. That means this one is probably going to be the most difficult one to adjust. By the way, if you need some lubricant or something in there, add it at this point. The spindle pulley is attached with this nut here, which allows me to move it up and down as well. But based on my inspection, I think all of my adjustments need to come from the center pulley, because this is going to be the most difficult one to adjust. If I didn't have a center pulley and I just had these two, I would make all of my adjustments based on my spindle pulley back to my motor, because this is going to be the most adjustable one. So the first thing we want to do is get a nice good reference straight edge here. And what we want to check is that our pulleys are in line, meaning they're all the same height. And the other thing we want to see is whether our pulleys are coplanar. So what I'm going to do is take a nice straight edge here and just lay it on top of my center pulley. And I'm going to just move it over the other pulleys and see kind of where we're at. Generally, my spindle pulley is a little bit high in reference to my center one, so I'm going to want to move it down a little bit. And you can see my motor pulley is even higher. It's probably about 1/16 of an inch too high, so that needs to come down. So what we need to do is loosen this nut here. The problem is that when you try to loosen this nut, obviously the pulley rotates. The way that we're going to prevent that pulley rotation is to come down here. We need to extend the shaft, and you'll have to rotate the pulley until you see this keyed area here. So I'm just going to insert that wedged metal piece in there like this, and then release it so that it rests up there, and now my pulley doesn't move anymore. So now I can come up here with a large wrench and just loosen this nut, which I've already pre-loosened. But what I wanted to note here is that this is left-hand threaded, so you have to rotate it the opposite direction that you normally would to loosen it. Otherwise, you're just going to keep tightening it down forever. And there we have it. Okay, so with my spindle in the down position, I'm going to use a piece of wood, see if we can't tap this down just a little bit. So I've got a hole, I've got a piece of wood with a hole in the center so that I don't hit this shaft here. I just want to put pressure on the pulley a little bit and not too much. So I'm just gonna give it a couple quick taps and see if that made any difference. So let's go ahead and recheck our pulley, see how we are. I found that depending on the pin position of the center pulley, it can affect whether my pulley's high or low. So to demonstrate, when I'm over here, we're almost level and a little bit high in some spots. If I'm all the way over here, the spindle pulley is always high. And if I put it to about the position where it was when I removed it originally, we're a little bit below or just about level. You can hear it dragging a little bit. And since we're just talking about pulley height, it's really not that critical to get within a few thousandths of an inch on your pulleys. We're not talking about run out at the, at the arbor or something like that. So I think this is pretty fine. The question is, what if this pulley is too low? Well, then you would need, a spacer block of wood and an angled breaker bar or something like that, and to sort of force it up a little bit. A better alternative to that is to actually just use a pulley puller where it has like jaws that you can clamp onto here, and then just a screw in the center that'll just push, that'll sort of pull this pulley up. But that's why you want to avoid making adjustments to this spindle pulley as much as possible. Okay, so we verified that the height of these two pulleys are about the same. Now we need to check coplanarism. Coplanarism can be affected by two different things, really. If these two shafts are not perfectly vertical and parallel, that'll obviously create this kind of an effect. The other issue may be that the pulleys are not attached to the shafts concentrically. So even if the shaft is straight, the pulley may wobble as it rotates. Those are the two main issues. If either one of these two pulleys weren't coplanar, or they were far enough off that I'd be concerned, I would probably just either replace the bearing in the center one or this entire assembly. And for this one, I would try tapping the high edge and see if I could just adjust the pulley on the shaft a little bit. I would just get a block of wood like this and maybe just tap it a little bit like that to see if maybe I can skew it a little bit. But honestly, if this one's not coplanar, you've got major problems. You may as well just return the drill if it's still under warranty. Or you're going to be basically replacing this entire assembly. I don't know of a great way to adjust coplanarism on these two otherwise. I will demonstrate how to do it on the motor assembly because that one's a little bit easier. But these, you're going to have a hard time adjusting these. So moving on to my motor pulley, we'll do the same thing as we did before. Lay our straight edge across the center pulley. And as you can see, the motor pulley is about 1/16 of an inch too high, so it needs to come down a little bit. Now I have two options of doing this. I can either move the pulley on the shaft up and down, or I can move the entire motor assembly up and down. Now which one of those I choose is going to be determined by whether this pulley is coplanar right now. If it's not coplanar, I'm going to have to move the motor assembly anyway, so I may as well just knock both out at one time. Now the first thing that I want to check is whether I need to make any front to back tilt adjustments to the motor. Basically, I need to know if it's tilted front to back like this, and I'm going to do that the same way I've been doing things, and laying a straight edge across this pulley surface, and then checking the gap between my center pulley, the front point, and my end point. And that'll tell me whether there's any tilt front to back in this pulley. The fact that the gap here and over here is roughly the same tells me that the tilt of my motor is appropriate. If I did need to make some adjustment to the motor front to back tilt, what I would do is apply some shims either at the top or bottom. I would apply shims at the top if I needed to move my motor this way, and I would apply it at the bottom if I needed to tilt the pulley this way. But my motor isn't showing any skew front to back, so I won't need to make any adjustments there. I just need to check side to side skew and then make sure that these pulleys are in line. So I'm going to grab my straight edge again, and before we were checking front to back skew, now I'm going to check side to side skew. And the way I'm going to do that is just rotate it across here, and you can see there's a larger gap here, and then as I rotate it through, it's hitting over here. Now the adjustment for this is exactly the same as the height adjustment for the pulley, which means the motor is able to move in two dimensions. It can go up and down and side to side. So when we move the motor, we actually have to tilt it this way a little bit. So if I'm facing the front of the drill press, we need to go counterclockwise. To do my side to side tilt adjustments, basically what I like to do is keep one of these bolts tightened down and the other three loose so that I can just rotate it around a single bolt until I have the same gap on this side and this side of the center pulley when I hold my straight edge on the surface of my motor pulley. On the adjacent bolt, have some wrenches already attached so that you can quickly tighten it the opposite one down on the other end as you rotate this motor assembly back and forth. So because one of my bolts is tightened, the other three are loose, I can basically rotate this motor freely around that one bolt by hand. And another thing I've done is I just put a feeler gauge across the diameter of the center pulley, and what I'm looking for is the gap across that feeler gauge. I'm just looking as I rotate it across whether that gap varies at all. And as I rotate the motor, once I get to a spot that I like, essentially what I'll do is I'll just tighten these wrenches down like this, and that should be it. Obviously, because I'm above the center pulley, I still need to bring this pulley down a little bit, but I don't want to make any more adjustments to the motor mounting bracket because it's going to adjust my tilt again. So I'll make my final adjustment at the motor pulley itself by loosening the set screw again and moving it up and down. So my pulleys are now in line with one another, and they're also coplanar, or at least as close as I care to get them. Hopefully you were inspecting the pulleys while you were doing this for any damage, and replace them as necessary. Now it's time to inspect the belts. Basically you're looking for any cracking or any other damage, delamination of the outside or anything like that. My belts are in pretty good condition, so I don't need to do anything here, but just go ahead and replace them as appropriate. The other thing I'm going to do is adjust the speed to what I want it to be. So one last thing that I want to demonstrate before leaving the subject of pulleys is that depending on your belt configuration for whatever RPM you select, it is going to tilt your center pulley one way or another, or at least it does on this drill press. So to demonstrate this, I have this current configuration with this belt on top, and then the other one on the bottom of the center pulley. And you can see now the center pulley is below the surface of the motor pulley. And as I increase tension, that gets even worse. You can see now it's well below the surface. And by contrast, it's well above the surface compared to the arbor pulley. So this is my final belt configuration. And because this belt is on the bottom, it's going to tend to tilt the center pulley upward. And so it is now a little bit above the center of the other one, which is to be expected. Now I could redo the pulley alignment, but I'm not going to do that because I plan on changing the RPM at some point. So now that I have my belts in their final positions, the last thing I need to do is adjust belt tension. And I'll do that just by cranking back and forth on this handle here, which essentially just moves the motor back and forth. So the spec on this is about 1/2 inch deflection, which is about right there. But the way that I like to do the belt adjustments is just based on sound. I'll turn it on in a second and I'll slowly move the motor back, and what you'll see is that if I adjust tension too much, these belts start to develop harmonics and they'll start fluttering back and forth because they're sort of fighting for this center pulley a little bit. And so what I'll do is I'll go a little bit too far, it'll start to flutter, and then I'll back it off until I think it's at its best position, and then tighten it down with the set nut here. And that'll be the last adjustment I do. And the whole goal of this is basically to reduce vibration as much as I possibly can. So here we go. So you can see it starts to develop a louder sound and more vibration if I tension it too much. So the goal is to back off on that is a little bit, so I'm about right there. And that'll be my final belt tension. Let's see about how much that is. It's a little bit looser than 1/2 inch. It's a good amount looser actually, but it is giving me the best performance. Last thing I actually need to do, and I forgot about this, was to put this spindle nut back on. Okay, so this is the final configuration. It looks pretty good. Not too much vibration. Let's go ahead and check it out. as you can see, it's walking a lot less than it did before. There's still a little bit of vibration, but I think it's acceptable. So now we can go ahead and move on to the rest of the chicks.